Hello guys, so today I'm going to explain you how can we solve this problem separating numbers. This is from a running contest July circuits. So yeah, you can see this problem, this contest is still running. I'm just gonna publish this once the contest is over, which will be over in almost 2.5 hours. So yeah, the problem statement says that we are given a tree with n nodes and each tree has certain color attached to it, and we are also given n minus 1 queries. In each queries we are supposed to remove some edge, and once we remove some edge, some pair of nodes gets disconnected. So we need to find out some pair, the number of pair of nodes which gets disconnected. And also there are certain condition that a pair of nodes gets disconnect, I mean two pair of nodes are said to be disconnected only if before the destruction of the edge we were able to reach from either node to the other one, and if both of these node has the same color. All right, so yeah, let me explain you this example here. So basically we had let me just explain you the input format first, and I'll explain you this particular sample test case. So we are given n as the number of nodes and then n minus 1 queries, n minus 1 edges to build the tree, and then this n numbers, that means the 5 integers here shown, says the color of the each node, and then this is the order in which we need to destruct the tree. Like we need to destroy each edge. Like we will first destroy the edge second, and then first, and then third, and then fourth. So yeah, let me quickly explain you how this comes to be 2010 in this case. So yeah, I've taken out this example from the given sample case here. We were given 5 different nodes, and each of them had different colors attached to it. We had certain edges, so I've drawn all of them. Like 5 to 4 is the first edge, 5 to 2 is the second edge that is given, and then we have 3 to 2 and 1 to 2 as third and fourth edge. 3 to 2 and 1 to 1 and 2, we have the fourth edge. And then we were also given certain colors attached to each. So first, third, and fifth node has same color. That means 5, 1 and 3 has, I have marked them as blue. And then we have second and fourth as different colors. So second and fourth respectively red and green. Now what are we supposed to do? We need to destroy these tree by first deleting the second edge, then the first edge, then third, and then fourth, the same order which they are given here. So second edge is this one. We need to first destroy this one. So what happens once we destroy? We need to find out how many pairs of node gets disconnected. So for example, if there was no such node here, let me just try to remove this one. So as you can see, there are 2 pairs which gets disconnected. I mean, they both have the same color. I mean here 5 1 and 5 3. So 5 1 gets disconnected because now we can't reach from 5 to 1, and also from 5 to 3 we can't reach. And you can see as well that they have same color as blue. So for the first query, the answer is 2, which is correct as you can see here. And then the next query is we need to remove the age 1. So if we remove this age, what happens here is we need to see how many more pair of nodes gets disconnected. So once we remove this one, we can see there is no more no extra pair of nodes are getting disconnected. So the answer for this case would be 0. Now let's remove the next one, which is third edge. So we need to remove this edge. So let me just remove this one as well. So what happens once we remove this? Now we cannot anymore reach from 3 to 1 or 1 to 3. So basically there is one pair of node which gets disconnected here. So answer for this case is 1. And then similarly, if we remove the last one, you can see that there is no more extra pair of nodes getting disconnected because the colors here are different. And yeah, so the answer for this particular case is 0. So how are we going to approach this problem is a very tricky one. So if one tries to actually remove each edge, that is going to be very difficult. We need to travel the whole tree and calculate how many pair of nodes are actually getting disconnected. So we were given some queries, and these queries were in this particular order, that we need to first remove edge second, and then one, and then three, and then four. So what is happening here is basically, as the problem statement says, that we in each queries we are supposed to destroy a previously undestroyed edge. So ideally what would happen in the end is that the whole tree gets disconnected. That means as we saw previously, that once we disconnect this, all of these edges, destroyed all of these edges, each of these nodes are disconnected and they become a single tree, single node tree. So meaning that in the ideal situation, what we can also think in terms like going in the backward direction, instead of destroying this tree, what happens if we were given with some, let me just first quickly remove all of these, like we were given this query in the opposite direction, like 4 3 1 and 2. So instead of destroying this tree, what are we supposed to do is, now we supposed to build the tree by first adding the fourth edge, this, that means this particular edge. And if we add this pair of edge, how many pair of nodes are getting connected instead of getting disconnected, so which is equals to what we'll have. So for example, let me just say we had this node in the end and we are on the last query. All right, so if we were to destroy this fourth edge, then the number of pairs of nodes gets disconnected will be equal to, what we can say is, once this pair of nodes were already disconnected and we build a tree, and then we'll find out how many pair of nodes are actually getting connected. So now this would be a bit simpler, because what are we gonna do is, we are gonna build this tree by adding these nodes or adding these edges into the tree, and then keep on counting how many new pair of nodes which are getting connected. So the pair of nodes being connected would be very much similar to what we have the definition for pair of node getting disconnected, and that will be how many pair of nodes are generated such that we can reach from one node to the other node, and both of these nodes have the same color. So for example, if we talk about this one, so let's just run through our example, that if we were to add the fourth edge first, then what happens here is uh, we see that there is no pair of nodes are actually generated. So the answer for this one would be 0, because this one was red and this one was blue. Right, now once we add this particular edge, so now what happens is we get, so earlier there was this particular set already available and we added one more node to this particular set, I mean this tree. So what will happen now is we get one pair such that their color is same, and we can now reach from one to other. So the answer for 3 is 1. Now let's add this one, the first edge. How many more node we get, pair of node we get, that is 0, right? And then once we add the second edge, what happens is we can see that we have opened two paths from this edge by adding this edge from this node to this and this node to this, and they both have the same color as well. So answer here would be 2, which is similar to what we have, and we just need to print them in the reverse order. All right, so 2 1 2 0 1 0, this is what we had here, 2010. So now that we have seen that instead of destroying the tree, we can also approach in this manner, which was a bit tricky to find out first, but yeah, once you spend some time, you'll be able to definitely get to this. Now let's try to think how can we actually keep adding these nodes to the already built tree, and how are going to we find the number of pairs which are getting connected. So basically we are going to use disjoints and union approach to build this tree from scratch, and we are going to pick these edges in the reverse order. And if you're not very familiar with the disjoint set union, I would highly recommend to read about it first. And yeah, I'll try to briefly explain. So initially all of them are a disjoint set in itself, like all of these nodes. And what are we going to do is, with the time, we are going to merge each of these set into one another. How are we going to merge? So basically, initially, let's say we will pick the first edge, that is the fourth edge, and we will get two nodes here, and two nodes, basically two sets. And let's call these 1 and 2. So we are going to find the first the let's say for example, what happens once we merge a set which has only one node in itself, like both of them had one node. So we have to merge one into the another one. So basically this will become 1 2, and then we are going to make one of these nodes as so basically we will add this edge here, and then we are going to assign one of them as a parent of this set, so that we once we are going to consider adding another set or adding merging another set into this, we will have to only interact with one node from this set, not to the all of these nodes. So basically, to sum it up, we have two things to do. So first thing is to first find the parent of each set. And once we have find the parent, so basically even in finding the parent, there are certain optimization that we can do, that is called as a path compression, which we will see in a moment. And then the second is that once we have find the parent, we are going to merge them. So merging we also call union, make union. So basically, once we are left with two sets, I mean once we have found out their parent, we have, let's say, called two sets. And then we are left with the choice to make either merge A into B or B into A. And we will use a union based approach, ranking technique to make this union. And if this is not very clear, I'll recommend you guys to first read about DSU. These are the very simple and very well-known standard approaches, which are very helpful in such problems. So yeah, once we find the parent here using the path compression algorithm, and then we decide based on the ranking. So if the A is having the bigger rank, then we are going to merge B into A. And then to find the number of node, what we can do is we can keep initially all of these sets are individuals, all of these nodes are individual sets. So we can assign a number of nodes each sets carry, I mean number of colors of each type each node is carrying or each set is carrying. So once we merge them, we borrow all these colors as well from the one set to the other set. So basically here, for example, initially one was carrying only one of blue, and this was carrying one of two. Now once this gets merged, so this whole set is represented by, for example, one. Then one would carry one for blue and one for red. All right, so now once we are going to merge this with 3, then we will check that 3 has already 1. So we will find that 3 and 1 would make one more pair of node that is getting connected. So answer here, once we added 2 and 3, we saw previously that the answer would be 1. In this case it would be 0. And then once we added here, we saw that, yeah, 1, because 1 had 1 blue and 3 also had 1 blue, so this one will be the answer here would be 1. And also this will be borrowed by 1, because we said that we will keep 1 as the parent, because we will merge 3 into this one, and in that case blue will become 2 here. And then we'll have this set. Then the next one which we saw that would be this one. This is getting added here. It was 1 for blue, and here it has 1 for green. And in the end this will be borrowed by 5, I would say. Let's for now assume that this was borrowed by 1 for 5, and meaning the 5 is the parent of this set now. And this we can clear it out. And then in the end, once we are going to merge this node as well, we can see that the 5 has 1 blue, and this the representative of this set, which is 1, had 2 blue. So basically we will have 2 into 1, that is 2 for as the answer here. And previously, yeah, I forgot to mention the answer for previous connection was 0. And this one, because we had 1 blue here, 2 blue here, it will be 2 into 1 2, and this all is also borrowed to 1. So basically in the end we will have 3 blue and 1 red and 1 green for the parent of this whole tree. Yeah, this is the basic approach that we can follow. And now let me explain you what went wrong. Yeah, I'll explain that particular thing in while explaining the code itself. So let me quickly explain my code here. These are the input I'm taking. As we need to traverse the whole edge in the reverse order, I am trying to store each edge that is given to us. So basically I have declared an array of pair of integers, and I'm gonna store each edge in this array of edges. Then as we've seen that we also need to carry the color each set is maintaining, the count of each set, each color as well. So I have declared a map, I mean basically an array of map, where each element in this array is a map saying that all the colors maintained by this particular set. So initially all of them would be given a particular color, and all of them would carry their own color first. And here is what I'm doing for that. Then we are given these queries, and we need to store these queries as well, because we need to process them in the reverse manner. Also I have initialized our disjoint sets initially. So initially each of these rank, yeah, I have written size here, but indeed I mean they are the rank. So I have declared each of them as 0 initially, and each set is, I mean each node is the parent of itself in the beginning. Then I'm going to process each of these queries in the different in the reverse order. So basically I am finding the query i's first node and then second node, and I'm going to make a union out of it, and whatever answer I'll get, I'll store into a different array, and then I'm going to print out of all of them. So here is what I'm doing in the make union function. I'll first find the parent of each of these set, as we have seen here at certain moment, as we have seen in this case. This is not a single element, so this will contain certain number of elements, and we will need to find the representative of this set, and also we need to find representative of this set, and that's what I'm doing. So to find the representative, we use this function called find parent, and we are using simple yeah, DFS based approach to find this parent. Merge any of the set into the other one. So I have decided to merge B into A again, and in that case we need to increase the rank for one element where in which I'm merging the other one. So I am merging B into A, so I have increased the rank for A. So yep, that was the union approach, and in the end I'm returning the answer here. And there was one glitch in the problems test cases, because of which a lot of people felt frustrated, including me as well. So the problem was that in 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 reality each of these edges should be given only once. That means as also stated in the problem statement, that we are told to destroy each previously undestroyed edge. That means the the last line here would always be a permutation of 1 to n minus 1 actually. But because of some faulty test cases, we have seen some duplicate edges here, and because of that we, so basically this can also happen that we are given some queries which has 1 2 1 1, like when we are adding the one this age 1 multiple times here. And ideally if that happens, what will happen is we will get A and B both as 1, and because this is tree, that should not happen. That means the parent of these two sets shouldn't ever be same because of tree. So, and this will only happen when we are going to add multiple edges along, or I mean parallel edges, or make cyclic, make this one a cycle, which is not the property of tree. But unfortunately there were some test cases which included such case where it would make a and b equals once we find their parent. But yeah, as we have seen, this is not the valid test cases. But overall, yeah, the problem was very nice. I really enjoyed solving this one. It's just because of their faulty test cases, and the whole interest of a lot of participant was lost in this problem, including me. I also felt not so enthusiastic while solving this one, but once I started solving, I found this one very interesting. So yeah, I hope I was able to explain you guys properly, and if there is any feedback or any comment for me, please let me know in the comment section below. And thanks for watching this video, guys.